Hello, good morning. My name is Jacob Thompson. I'll be introducing to you the WITMARS system. It uses blockchain and leverages some of the smart contracts that are already in use. We're going to be looking at the ledger that's used on the Ethereum network and how we can integrate something very, very similar for our uses and our use cases today.
Here is a basic introductory to the entire WITMARS system. WITMARS stands for Wallets Integrating Tokens for Manufacturing and Response Services, or Wallets Integrating Tokens for Manufacturing Assets and Response Services. Basically, all we have is the Army Asset Network that creates and displays the ledgers of the requests. After here, inside the Army Asset Network, it'll generate and distribute tokens to token administrators. These token administrators are just wallets that are then able to receive and distribute the appropriate tokens to both Army supply administrators and manufacturing administrators. So all we have is an Army service admin over here who receives the services, and a manufacturing services over here, services admin over here, who sends the services. The Army service admin details the specific requirements or the details, sends the token to the manufacturer along with the WITMARS requests, or they just get the token from the token administrator. But so they would put in the request and they would wait the response from the vendor if there is a request. And the token path for the normal manufacturing supplier to the Army service admin is they prepare the service, send the service token, and then when this comes here, if the Army service admin says that the service is requested and he validates the service and data details, then he accepts the token and validates the token. So, good morning, ladies and gentlemen. Today I will be presenting a robust and featureful presentation of the WITMARS system. WITMARS stands for Wallets Integrating Tokens and Management Asset Response Services. And the main purpose of this deployment is two things. Number one, producing an accurate and immutable ledger to score and maintain all of our crucial and critical data points required in order to accurately measure, maintain, and iterate over those systems with remote capabilities. Once this ledger is created and deployed, an application programming interface or API may be built out on top of that for hosts and a plethora of systems in the future for manufacturing and or deployment, all while using existing technology that is undoubtedly preparing the Army to be more agile, effective, efficient, affordable, and scalable, and most of all, secure and reliable. Number two is also to maintain the needs and the requests of each Army request, or whatever their specific details are from the manufacturer. The mission for this technology is to make it to improve the efficiency or effectiveness in the current engineering practices. So here we're looking at cost, safety, cycle time, necessary manpower, and readiness. Rule number one is you cannot fix what you cannot see. So first we will be clearly implementing our ledger with these data points. Then we'll be able to measure them and improve them. Our critical mission points are cost, safety, cycle time, necessary manpower, and readiness. When setting up a distributable ledger database, here's a suggested data format for those measurements. Cost, a number amount that is relative to the value in US dollars, like $25.67. Safety, let's say it's a number between 1 and 100, measuring the safety of a task or item. Cycle, an input of numbers in the hours, seconds format. It says how long it takes. For example, this says this took 4 minutes and 30 seconds to manufacture in this or that cycle time. Necessary manpower, an input of numbers in the hour, minute, second format, or a number in hours it requires manpower, and the number of people it requires for the task. So just for example, 45 minutes and 30 seconds with 3 people. In 45 minutes and 30 seconds, it took 3 people to unload a truck. Readiness could be an input of numbers in the same hour, minute, seconds format, and it can just be the time from start to finish it took from start to finish for deployment. So for example, in 4 minutes and 30 seconds, that's how long it took us to deploy a tank 20 miles away. Request detail can just be a text box if there's a detail from the Army service admin to be requested. For example, when transporting nuclear material, follow this checklist: seal container type, and number, labels, and last location identified. Secret materials are recommended to be ran on a separate secret network or a secret materials network. All of that is then logged into the table, or possibly two tables. I'll show a demonstration of that here in just a moment. And so for a quick example, we can say on this ledger, this is my wallet address, and it shows the last transaction sent. It shows the address, the method, if it was something transferred or something minted, the block, the actual age, the to and from memory address, as well as the just general amount for it calls for the network to run. And lastly, here's a table that's an example of the same kind of format we've had before. If we say for an M1 Abrams tank, let's say the cost would be $500,000. The safety could be 89 out of 100. The cycle time would be 4 hours, 4 minutes, and 30 seconds. The manpower could take 45 minutes and 30 seconds with 3. The readiness could be an example like 000430. And a detail could say 100% steel with tungsten rounds. Both of these ledgers could have an API built out and should be for more development capabilities. And as a way to set this up, if you were to say this is the Army Asset Network, this is the token admin, this is the Army Asset admin, and this is the Army Manufacturing admin. The Army Asset Network is started, it generates tokens, and it's given tokens to the token network admin. This then distributes them to the Army Services admin and the Manufacturing admin. And the Army Services admin does not receive any services unless he verifies that token, and everything is verified when he gets it.